Right now, I am working on a project called Orchid that takes math, something I think we can all agree is fairly sexy, and transforms it into something that is dangerously sexy. Now then, some of you schmigs may be wondering, Danny, I don't like math. I never have. What could possibly make Orchid so dangerously sexy? To your first point, let me humbly submit that the reason you probably don't like math is because the way math is taught, K through 12, is kind of a total dumpster fire. To your second point, what could possibly make Orchid dangerously sexy? Well, that's precisely what this video is about. In order to understand why Orchid is in fact a rare and distilled form of dangerously sexy math, first, I'm going to give you a brief overview of the software. We're going to look around in it, maybe define a couple features. Next, we're gonna have a fun little story time in which I tell you why I even started working on this project in the first place. And finally, with those two things out of the way, we'll be in a position to really lock down on the characteristics of Orchid that do in fact make it dangerously sexy. Before we get to the demo, however, if you could just take a moment to tap the like button for the YouTube God algorithm, I'd really appreciate it. Anyway, onward and forward. All right, so here you see the first initial page of Orchid. Now this page is basically just a very simple file explorer page. You'll see that I have a hello world page defined, and then I also have a rationals page defined. So I'm just gonna go ahead and open up the rationals page. And then what you see here is the more typical page that you'd be interacting with in Orchid. Probably the first thing you notice are right down the middle, all of these equations. I think it's important to note that these are kind of like textbook grade, well typeset equations down here. The second thing that you probably notice is everything that's happening over on the left side here. I'm gonna ask you to kind of ignore that for now, but just know that basically all of that is defining the relationships between the different equations. And that actually kind of comes down to the fact that Orchid is actually doing something pretty magical in that not only does it allow you to very easily create these very well typeset equations, but actually all of these equations are internalized in a series of data structures. So Orchid actually understands what's happening in the math you define. And so basically everything that's going on there is happening on the left side. And again, we're just gonna kind of ignore that for now. Some of you may have noticed the universal qualifier. If so, 10 points to Ravenclaw. So here I'm just defining the axioms of the rational numbers. If you don't know what the rational numbers are, don't worry about it. Doesn't really matter. I'm more interested in just kind of showing you what Orchid is, how it works, and just giving you a general idea of what's going on here. So a couple things to see. Right down here I have the associative property, commutative property. These are what you'd expect from the axioms of the rational numbers. Down here, distributive property, couldn't get away without that bad boy. And further down here I have defined the ordering structure on the rational, this less than or equal to operator. Just to give you a general idea of kind of what it's like to work with Orchid, what I'm going to do is define the rule that basically says if A is less than B and B is less than C, then A is less than C. It's the transitive property. So like if 1 is less than 3 and 3 is less than 10, 1 is also less than or equal to 10. So I'm just going to do that down here. And I'm going to use these three variables. Basically again, you don't really have to worry about this, but what's going on in this whole block here is it's saying for all A, B, and C in the rational numbers, and then I'm going to quickly define a new property here. I'm going to first create a new equation and say less than or equal to A, B, and boom, just like that, I have that equation. Again, less than or equal to B, C. Again, super easy, have that equation. Then finally, I'm just gonna create another equation down here and say less than or equal to A, C. And then once I commit that, now, kind of as I mentioned earlier, Orchid has actually internalized this. So it understands that for all the rational numbers, if A is less than B and B is less than C, then A is less than C. So not only do we have these kind of definitions as well typeset equations, but they're actually rendered within Orchid as these very efficient data structures. But anyway, so this is just kind of a quick overview of Orchid. I think probably just one more thing to note. If any of you have used LaTeX or something like MathJax before, you know that typically the way it goes is you write down a string of characters and then it renders it, and it isn't a very interactive thing. And so one super cool thing about Orchid is how kind of interactive it is. So even though these equations are very well typeset, I can click on any of these and the equation is automatically re-rendered with the cursor in the proper position. And not only that, a small portion of you have maybe used Vimium, and so what I can do is I have actually a similar functionality, so I can actually directly from the keyboard navigate to any of these specific terms, and then I can go up and down. So I at least certainly really enjoy looking at this. So anyway, with that out of the way, now let's get on to kind of why I started doing this in the first place. Now then, after seeing a little bit about how Orchid works, some of you viewers who are more plugged into the world of math magic may have a new question on your minds. And that question would be, Danny, I get it. Orchid looks pretty neat. It looks pretty fun to work with. That being said, aren't there literally a gazillion different pieces of mathematical software out there? The answer to that question is yes, there are. Ever since computers were developed, people have been writing more and more mathematical software. So then, in order to understand why I've actually taken the time to go through and actually develop Orchid, we have to go back about a year and a half ago to a time that I was sitting in the law library at Berkeley having a real bad time. I only mention the law library because I was strictly not allowed to be there at the time, so I think we can both agree that I'm basically a registered bad boy. The reason I was having a bad time down in the depths of the law library is because I was working my way through this here book on quantum field theory, and my primary issue wasn't actually the difficulty of the physics, even though that was an issue. My biggest issue was the fact that the equations I was dealing with were basically the entire width of a page, and so anytime I had to make some very small algebraic manipulation, I had to rewrite the entire equation, which is horrible because it's just cumbersome, but also because if you make a mistake, it's really hard to go back and figure out where the mistake was, and then you have to go through the entire process and do it again. And so yeah, I was just getting real fed up. But then I remembered computers are a thing. So basically, after getting slapped around by QFT for a while, I decided that I wanted a piece of math software that could do three main things. First, regardless of anything else, I wanted the output of the software to basically look as good as a math textbook, so that I'd be able to show the people what I was working on and they'd be able to understand. Second, I wanted to be able to define the relationships between the different terms that I was working with inside of the piece of software so that I could make an algebraic manipulation to some equation, and then the computer would handle actually doing the manipulation and re-render anything, which means that I literally wouldn't be able to ever make a mistake because the computer is handling all of the rules, and second, I wouldn't have to constantly be rewriting everything, which are two huge dubs. Lastly, I wanted to be able to define new mathematical entities, because a lot of the structures that you work with in QFT are kind of ill-defined and typically aren't very well supported by big pieces of math software like Mathematica or MATLAB. To make a long story short, I basically couldn't find anything that fit my basic requirements. A lot of the bigger pieces of mathematical software out there, like Mathematica or MATLAB, are effectively these gigantic calculators that are super good at chugging through these massive computations that happen to be very useful to a lot of people. But at the same time, they're not good at handling newly defined entities and working with your own set of axioms. On the flip side, there are a ton of projects out there that are like assistive theorem provers or automated theorem provers that allow for kind of the creation of new entities, but at the same time, it seems like all of them have this crazy high learning curve, and a lot of them end up looking more like a programming language than actual math. And so they end up being very inaccessible. So eventually I just decided, just screw it, I'll make my own thing. I just have to create something that fulfills the three base requirements. That shouldn't be particularly difficult, right? Wrong! Orchid turned out to be the most difficult project I've ever undertaken, both from an intellectual and organizational standpoint. And I mean, I don't know, it very easily could have been easier for some of you big brains out there, but for me, it was just really freaking hard trying to figure out how to convert math into code. So yeah, anyway, I've been at this for about a year and a half, had to rewrite the code base like 3 times, mostly due to my own bad code, but also because set theory betrayed me. Anyway, but yeah, so now it's kind of at a point where I can finally share it with people, so I'm excited to see kind of what happens after this video is released. Anyway, first YouTube video, woot woot. Now then, to kind of close out the video, I think I'd like to give one more quick demonstration to really demonstrate why I think Orchid is so freaking sexy. Okay, so here I have another page pulled up in Orchid, and I really haven't done that much. I basically just defined the real numbers type, this kind of stylized R. And so what I'm gonna do, and kind of what I wanna show you is how easy it is to define kind of new maps, new terms. So I'm gonna define addition and define the associative property on addition. So I'm just going to commit this first one, and then to define addition, basically, I can just do this. And also, I will have a future video that gives a kind of a better tutorial of Orchid. But for the time being, I just kind of want you to take notice of how quickly I was able to write out that expression. basically how Orchid works is every kind of term in Orchid is associated with a particular key, and so all you have to do in order to write equations is you type out the key, you press enter, and then Orchid turns that key into the actual structure, thus rendering it. And so now you'll see down here, if I open this, Orchid is taking note of the fact that I actually defined a new term here. I defined this plus sign, which we know is addition, but Orchid doesn't actually know what addition is yet. And so what I'm going to do is I'm going to define a new custom compact representation for this. You don't really need to know the difference between custom compact or anything else right now, but basically all you need to know is I'm basically defining the LaTeX template that Orchid will use to render addition. So what I'm going to do here is I'm going to just quickly type this out, and basically what this expression means is that I want, when Orchid sees addition, I want it to put its first argument over to the left, and then a plus sign, and then the second argument over to the right. And you can see this kind of example down here of how it's rendering a plus b. So now I'm going to save that. And so now, while Orchid still doesn't really fully understand what addition is, it at least knows how to render it in terms of the LaTeX. So I'm just going to commit that, and we're going to close that out. And now, just to kind of show you how easy it is now to access the addition term, I'm going to define the associative property. So what I'm going to do is I'm first going to bring a couple variables into scope here. So I'm basically going to make a statement that says for all, wait, 3, let's do that. Okay, so I'm basically just bringing 3 variables into scope. I'm going to say A, B, and C. I'll commit this. And so basically the statement is saying for all A, B, and C, and now I specify what happens to A, B, and C. So I'm going to add a new equation, and then notice, so I type out the equality sign, and then when I press enter, it expands that to what it knows is equality. And so now I'm defining the associative property, so what I can easily do is type out the plus, and then from before, it knows, because I just defined, it knows to render the LaTeX like this. So it's expecting its first argument here and its second argument there. And after I've actually finished up writing this, we're gonna have a bit of fun with the LaTeX, just because this is actually a really, really cool feature. So anyway, what I'm gonna do is I'm going to do another addition and say A plus B, and then C, and then over here, I'm gonna do A, B plus C. Okay, so yeah, I don't necessarily expect you to be following along exactly with everything I'm doing. I more want you to take notice of how quickly I'm able to create this expression. So I'm gonna commit this. Another cool little feature that I've added to Orchid is that I allow comments, and these are actually typeset with LaTeX as well. And so I can say the associative property, and just to show you that it renders LaTeX properly, I can add this little bit, which if you know LaTeX, you'll know that will render the stylized R. And then bada bing, bada boom, we have the associative property on the set of real numbers. Okay, so that's pretty neat. And as I kind of mentioned before, all of this is internalized inside of Orchid. So Orchid now kind of has a mapped representation of what this property means. But to kind of show you something really cool here, I'm going to actually change up the LaTeX representation of addition. If I just change this to something a little bit more funky, I'm going to do something like omega, let's see, omega 0, and then, okay, so now instead of rendering as you would normally see addition, it renders it with this kind of silly form. But if I press save, you'll notice everything automatically re-renders, and so now it thinks that this is the proper way to format addition, which I don't know about you, but I think that's really cool. And then as I kind of mentioned before, you can still kind of iterate through all the terms. You can click on the individual terms. It knows what to do. It's rendering everything, and it has the template inside of it. So quite honestly, if this isn't dangerously sexy math, I am not sure what is. So yeah, that's about all I have for you today. As I mentioned before, if you could just slap that like button, I'd really appreciate it, just so that it can help me hopefully find people who are also interested in using Orchid. If not, whatever. In terms of the whole subscribing business, let's just say, if you like the juice I'm brewing, you know what to do. I'll have more videos coming along in the future, probably about a couple different topics. I will definitely be releasing a kind of more full-length tutorial about how Orchid actually works, kind of from a more rigorous perspective. So yeah, stay tuned for that. Anyway, thank you so much for watching. I'm out.